Hello, welcome to ICMR NIE's online course on causal inference from observational studies, NICER 201 course that we call as CAUSIT. The topic that we'll cover in this session is titled as Epidemiological Approaches to Causal Inference. A central problem in any public health or clinical research is how to make inferences about causal effects of actions, behaviors, various exposures or intervention. In this series of sessions, we'll review various epidemiological approaches that provide the basic framework to making such inferences, focusing specifically on observational studies. And why so? Because in observational studies, the treatments, interventions, exposures are not necessarily randomly assigned, and that can be the source of bias in making or during the causal analysis of such observational data. Certain background assumptions and sources of bias are more easily seen with certain approaches or models that we will be seeing subsequently in these sessions, whereas practical statistical procedures may be more easily derived under some other models that we see. We focus on the insights facilitated by each of these approaches and the various connections and translations among these approaches. This topic will be divided into 4 broad sessions. The first session will try to understand how to define cause, and then we'll go specifically into the various epidemiological approaches or models to help us to understand how to design our studies and how to analyze data specifically from observation studies, namely the sufficient component cause model, the graphical models, and then a series of more quantitative models such as the potential outcomes model, the structural equation models, and the methodological models. So let us go straight into the first session, which is about defining cause. The search for definition of cause has a long history to it. And there have been various philosophers. In fact, it was a topic of philosophy before it even came into the realm of what we know as the modern science. Here, I'd like to specifically bring to attention the work of David Hume. He was a Scottish empiricist philosopher, one of the British empiricists of the early modern period in the history. And he is known for applying various rigorous standards to understand causation and necessity. Instead of taking the notion of causation for granted, similar to probably his contemporary philosophers or philosophers before that, the way they had done, Hume actually challenged the readers or the scientific community to consider what experiences allow us to know about the cause and effect. And in fact, Hume's most important contributions to the philosophy of causation are found in 2 of his seminal works. First of one was a treatise of human nature. Following that was an inquiry concerning human understanding, which was generally viewed as sort of a rewriting or a recasting of the former work. Based on his work, what Hume proposed as a cause, I'll read this out, or you can see on the screen, we may define a cause to be an object followed by another, and where all the objects similar to the first are followed by objects similar to the second. So what that specifically means, so if E is an event or an object that happens first, and D is an object or an event that happens subsequent to the occurrence of E, then whenever we see E and it is always followed by D, then we can call E or consider E as the cause of T. So you can think of various examples of this is basically in the realm of observation, that whenever you see somebody say smoking, and whenever that is followed by people being, say, diagnosed with lung cancer, and if this happens every time, we see that whenever somebody is smoking, there is lung cancer, somebody smokes, there is lung cancer. And that's what Hume meant by saying that then we can say that smoking is the cause of lung cancer. However, we also know now, probably which was not as well understood during Hume's times, was that this observation of seeing one object being followed by another, and that happening many number of times, may just be coincidental, may just be something that happened by chance. And probably this definition of cause would not hold true if out of, say, the 1,000 times that you see D being followed by subsequent to E is when if D doesn't happen when E is there. So if you see somebody or a population with a certain level of smoking habit, but you don't see a similar kind of distribution of, say, lung cancer, then we come into a dilemma whether smoking is the cause of lung cancer or not. In his subsequent works, specifically in the inquiry concerning human understanding, Hume actually added one more sort of layer to his definition of cause, which actually makes much more sense when we think of causation. And what he added was that now where if the first object had not been, the second never had existed. So if the exposure doesn't happen, you wouldn't see the cause. Right? And that seems to be more practical and a sort of more clearer understanding of what a cause would be. So in the strict Hume's sense of definition of cause, we could then divide causes into basically two categories. If we go by Hume's definition, a cause could be a necessary cause or it could be a sufficient cause. When we say a necessary cause, what that means is the outcome or D would happen only if E was present. So in the absence of E, D would not happen. And a sufficient cause would be defined as the presence of E is sufficient enough for the occurrence of D. So although D could occur due to the presence of maybe some other factors, but if E is present, it is sufficient enough to show that D would occur. Now, if we start thinking of what could be the examples of the such necessary and sufficient causes, that is where we to some kind of a dilemma, because if we think of necessary causes, mostly what you can think, so if you want to say is like, so if we say that the exposure to, say, tuberculous bacillus is necessary to cause the disease tuberculosis, right? In order for AIDS to occur, it is necessary to have the HIV virus, right? So in that sense, these etiologic agents or the pathologic agents can be thought of as the necessary causes for these diseases. However, in a way, these examples are what kind of man-made in the sense that we've labeled the disease based on the organism, right? Again, coming out of the infectious disease paradigm, if you look at, for example, postpartum depression, right? So what would be a necessary cause of postpartum depression? Having delivered a child. So in order to say for somebody to, or a woman to be diagnosed with postpartum depression, right, the necessary cause would have to be delivery of the child. So again, the name of the outcome itself, postpartum depression, tells us what the necessary cause is. But in today's time of multifactorial causation, we may not be able to actually pinpoint a specific that a necessary or a sufficient cause for various diseases or health outcomes that we encounter. And hence, we need to go further into the more recent modern epidemiological approaches to understanding causation. Before we go into further, finally, what the current sort of best definition of cause could be, let us try to understand some of the other terminologies that we encounter when we are looking into causal inference. And one of those terms is the word effect. The term effect can be used in sort of particular sense. In one sense, it would be, say, effect can be seen as any case of a given disease that may be the effect of a given cause. Right? So there is the effect of an exposure or an outcome. So it's the endpoint of a certain exposure or causal mechanism per se. For example, say HIV infection is an effect of unprotected sex, right? Where unprotected sex is one of the several causes of HIV, and being infected with HIV is also seen as one of the potential several consequences or outcomes of being exposed to unprotected sex. Strictly epidemiologically speaking, we understand effect or the effect of a factor or an exposure is as a change. So, for example, if the disease frequency is measured as a proportion, then the effect of decrease, say, for example, the effect of a decrease in unprotected sex, so people, more proportion of people, say, using condoms, for example, less number of people using condoms would result in increase in proportion of people infected with HIV. So now the effect of a factor or an exposure is basically can be defined as a change in a population characteristic, the outcome caused by a change in the level of certain factors, which we call as exposures. In epidemiology, we refer to potential causal characteristics as exposures, right? So this could be any kinds of behaviors. This could be some, say, drugs, vaccines, any other public health interventions, specific traits, say gender, or say some genetic traits, some socioeconomic traits. Sometimes a particular disease could be considered as an exposure factor to cause another disease or its complication for that matter, and so forth. Another important thing to understand when we are thinking of causal inference is to differentiate between the concepts of causation and what we call as associations or correlations. One event is said to be associated or correlated with another event if observing one, that means that particular event, changes the likelihood of observing the other event or the outcome. And then we say that these two events are associated with each other because when one changed, the other also changed. However, what we need to understand that some associations or correlations can be causal while others may not be. So not every association or every correlation actually represents a causal phenomenon. And mere statistics cannot identify this difference in terms of the correlation or the regression measures that we estimate from our statistical procedures. What we can say that if we are sure that, say, for example, X causes Y, then that implies that yes, X is associated with Y. However, what we usually see, specifically, especially in observational studies, is an association or a correlation between X and Y, here X being the exposure and Y being the outcome of interest. Now, there could be various reasons why we are seeing this association or correlation between X and Y. One, it could really be the case that X is the cause of Y, right? Then we are good to go. However, specifically being with studies which are more observational in nature, where the assignment of, say, for example, exposures is not random. There could be other reasons why we see an association or a correlation between X and Y, which may be non-causal. It could be that actually it is Y that's causing X and not X that's causing Y. But when we see a measure of an association or correlation, we cannot distinguish the direction of causation. It could be possible that this association that we are seeing between X and Y is being seen, or it's sort of an induced association because of how we have measured X and Y. So we may have not measured X, either the exposure or the outcome appropriately. And hence, because of that error in measurement, we may be seeing this association or correlation between X and Y, which may again not necessarily be causal. Or this relationship between X and Y could have been induced because there is some other common cause of both X and Y, and maybe X and Y are actually not related to each other, but because of the influence of this common cause that affects both X and Y, we see when we just observe X and Y, whereas that third factor is hidden, we may see an association, but it may be just because of that. And again, that may be misinterpreted as cause. And finally, since in observational studies, specifically more so than in experimental studies, we look at the effect of X on Y among our study participants. And we have a way in which we select our study participants in our study. And it is possible that the way we have selected these study participants, and if the selection of these study participants is influenced by both X and Y, which should not actually be happening if we wanted to see, say, an unbiased effect of X and Y. This could be, again, a reason for why we would see an association between X and Y, which may not necessarily be causal. So the understanding of the various situations in which where we can or cannot say whether X is the cause of Y or not leads us to this current modern understanding of how a cause can be defined. So a cause can be defined as antecedent event, condition or characteristic that was necessary for the occurrence of the disease at the moment it occurred, given that the other conditions are fixed. So just to understand this definition better, we break it up into, so we've highlighted some of the key situations which will help us to define whether a factor is a cause or not. Right? So the cause of specific occurrence of a particular disease or health event or any outcome that we're interested in should be something that has preceded the onset of that disease or onset of that event that we are seeing it as an outcome. So the cause, the particular exposure should have happened before this outcome has happened, number one. Secondly, we have the word that it has to be necessary for the occurrence of the disease. What that means is that that particular disease or that particular event or the outcome would not have happened at all, or would not have happened in that particular time period, the reference period in which we are trying to say whether a particular exposure is a cause of a particular outcome, if that condition or event or characteristic was different from what it was supposed to be. There is also a time element. So there may be an exposure could be a cause of an outcome in a particular reference period, time reference period, and it may not be for another reference period. So we have to keep that time element also into consideration. And finally, other events or conditions or characteristics other than the particular factor or exposure of interest that we are interested in, and that may have led to the occurrence of this particular outcome that we are interested in. So in order to say that our exposure of interest is the cause of our outcome of interest, we have to see it in the context that those other factors, which we will call them as covariates, and that can also cause this outcome, are not changing at that particular time period, right? That's what that means with the last part of the definition, which says given that other conditions are fixed. So the only thing that changes is the particular exposure that we are interested in. And that happens before the onset of the outcome. And when the particular exposure is present or absent, we see a change in the presence or absence of the particular outcome of interest in a particular time period, and assuming that all other factors that can influence the occurrence of or the change in outcome are not changing as well. And that's what helps us to understand what actually a cause is. Now, how do we make use of this definition to make causal inferences from the studies that we do? So for that, we need to take the help of various what we call as causal models or various approaches to understanding or to making causal inference. So because all causal inference ultimately is based on the assumptions that are included in the definition of cause. And so we take the help of various causal models. That includes the sufficient component cause model, graphical models, the potential outcomes or the counterfactual model, the structural equation models, and some methodological models. These causal models help us by abstracting particular elements of a causal phenomenon while discarding the details that get in the way of deriving any useful theory about causation. And they provide insights about the phenomenon of the study. The different approaches basically provide us with complementary perspectives and actually can be employed together to improve the causal interpretations of conventional statistical results. In the next session, we will go into more detail into each of these causal models or epidemiological approaches one by one. See you in the next session. Thank you.